The greatest engineers in human history may be the ones whose names we do not know. They left behind no blueprints, no signed monuments, no instruction manuals, but they left behind proof: massive stones, perfect alignments, structures that have survived thousands of years of earthquakes, storms, invasions, and time itself. And modern science still struggles to explain how they did it. At the Giza Plateau, colossal pyramids rise from the desert floor. Each stone block weighs tons. Some weigh far more. They were quarried, transported, lifted, and placed with astonishing precision. The Great Pyramid aligns almost perfectly with true north. Its internal chambers are positioned with mathematical accuracy that challenges modern surveyors. No steel cranes, no GPS, no engines, just knowledge. But whose knowledge? History remembers kings, it remembers pharaohs, it remembers emperors. It does not remember the engineers. At Machu Picchu, high in the Andes Mountains, stone blocks interlock so tightly that not even a razor blade can slip between them. No mortar binds them together, yet they have survived centuries of seismic activity. Modern earthquake engineers now study these walls. The stones are not rigid, they are dynamic. They move with the earth, then settle back into place. This is not primitive construction. This is advanced seismic design. Who taught them? At Pumapunku in Bolivia, stones appear carved with geometric precision so sharp and symmetrical that early researchers assumed modern tools must have been involved. Yet these blocks are ancient. Granite and diorite, harder than steel, were shaped with angles so precise they appear machine-made. Even today, replicating some of these cuts would require advanced equipment. At Baalbek in Lebanon, stones weighing over 1,000 tons were lifted and positioned into place. Modern cranes strain under similar weights. How were they moved? Ramps alone cannot fully explain it. Levers alone do not solve the scale problem. Some knowledge has vanished. In Rome, the Pantheon stands as the largest unreinforced concrete dome ever built, nearly 2,000 years old, still standing. Modern architects admit that duplicating it using identical ancient methods would be extraordinarily risky. Roman engineers understood weight distribution in ways that still impress structural scientists. They reduced density higher in the dome. They varied material composition by level. They engineered longevity. Roman concrete even grows stronger with time due to volcanic ash reacting with seawater. Modern concrete decays. Roman concrete endures. In Cambodia, Angkor Wat was not just a temple, it was an engineered environment. Massive reservoirs and canals controlled groundwater levels, preventing structural collapse. Only recently have researchers begun to fully appreciate the hydraulic genius behind it. Ancient engineers did not isolate buildings from nature, they worked with it. They studied wind patterns, solar movement, seasonal floods, earth vibrations. They built for permanence. They built for centuries, even perhaps millennia. But history is fragile. Knowledge can burn. The Library of Alexandria once housed countless scrolls, mathematics, astronomy, engineering principles. When it fell, what disappeared with it? How many architectural techniques were lost forever? Engineering knowledge in the ancient world was not centralized in textbooks. It was passed from master to apprentice, from generation to generation. When war came, that chain broke. When cities fell, expertise vanished. We assume progress is linear, but history tells another story. After Rome fell, Europe forgot how to build large domes for centuries. Sanitation systems regressed, infrastructure declined. Knowledge did not steadily rise, it fluctuated. Advanced skills can disappear, and when they do, all that remains are structures that confuse future generations. There is a quiet humility modern engineers express when studying ancient sites. They measure, they test, they model, and sometimes they admit, we are not sure. Ancient engineers did not have computers, but they had observation. They studied nature intensely. They learned material behavior through experience. They built prototypes at small scale. They refined techniques over lifetimes. They may not have written formulas, but they understood results. Some structures align with celestial events, solstices, equinoxes, planetary cycles. That required astronomical precision across generations. This was not accidental alignment. This was calculated design. The lost engineers of the ancient world were mathematicians without calculators, physicists without formal equations, architects without CAD software. They were problem solvers driven by necessity in survival, and perhaps most importantly, they built without the pressure of quarterly profits. They built for eternity. Modern construction often prioritizes speed and cost efficiency. Ancient construction prioritized endurance. That difference alone explains why so many ancient structures outlive modern ones. The uncomfortable truth is this: ancient civilizations were not less intelligent, they were differently focused. They studied stone, we study screens. They measured shadows, we measure pixels. They worked slowly, we work quickly. And sometimes, speed sacrifices understanding. The lost engineers did not vanish because they failed. They vanished because history is fragile. Empires collapse, wars erase expertise, languages die. And when that happens, knowledge dissolves. All that remains are monuments, silent witnesses to forgotten brilliance. The next time you see an ancient structure still standing after thousands of years, remember this: you were not looking at a mystery. You are looking at the legacy of engineers whose names we will never know. And perhaps the greatest lesson they left behind is this: human knowledge is not guaranteed to increase. It must be protected. It must be remembered, or it will be lost again.